I talked about it on Monday night on Discord, but the it started on Saturday. He was having his dinner, and he'd got me up really early on Saturday, so I was actually putting the Christmas tree up, and I got him his breakfast round about 11 o'clock, because that's when he normally has it. And he was going for it on his breakfast, and I was getting really close to finishing the tree off, and then all hell broke loose. All I can explain it as he face planted his food, and a noise that I've never heard come out of his mouth before, and it wasn't a seizure. But he lost all movement of his legs. He lost control of his back end, and he couldn't lift his head up. And after 20-25 minutes, he was still like that. So I tried to ring the vets, but I was 10 minutes late because they'd closed. I was hoping somebody might have still been there. So yeah, rang Mrs. OSK. I rang Tash to say I think you ought to come round, because I think this is it. If you want to say goodbye to Aston, I think now you better get your backside round here. And so she came round on just after dinner to give him some goodbye cuddles, and she could see what had happened. And then he slept for most of the day. Couldn't move, so every time he woke up, he made a grunting noise, and I thought, right, okay, he must want to go out. So I'm literally, his jumper. I'm literally holding his jumper, trying to suspend him so he can do his biz. Wouldn't take on water, so I had to syringe it in his mouth. Wasn't eating, didn't want to know. Even treats, didn't want to know. And then it was back to sleep. So this is when Tash was around. I mean, she didn't leave until 10 o'clock. I mean, she was really, really good. She'd bought a film round that I've not seen, and I talked about it on Discord. Remember, mate? I talked about it on Discord. And then on Sunday, I thought things were getting better. He was drinking out the bowl. He could lift his head up if he put his front paws in a certain way. Could lift his head up, and I thought, oh, everything's getting better. Here we go. We're starting to see movement. Hey. And then he had a massive seizure that lasted 7-8 minutes, and it wasn't the sort of seizure that you've seen Nico go through. It was like he turned into stone. It was like a statue. I could have picked him up and dropped him on his legs, and he would have been stood on them. It was like that for 7 or 8 minutes, and after that he wasn't there. So when he went back to sleep, I saw a little bit of him. He was taking on water, but I had to lap it into his face so he could know it was there. But and then on Monday I took him to see Sarah, the vet, and she's one of these people that and this one of the reasons why we went there is that they will not put an animal to sleep if they can heal him. And she looked at him and she just went and said, "I think it's time." And with that, Tash and I said goodbye to him. And that was sorry. So yeah, just after 2:15 he passed away. He was an old boy. Everybody knows he was an old boy. So he had a good innings. But yeah. So that'll be the last time you see the bed. Maybe when I pick him up on the first stream after I pick him up, I might put his ashes and the candle next so the camera can see it, so you guys can see it. I might put the two boys together just for one stream. But yeah, so as you can tell, I'm not as bad this time as I was with Nico, because Nico was so sudden. And I had an entire weekend to prepare for the worst. So, yeah. But I'd like to say thank you for everybody that has given your support to me. It's been much appreciated. And the guys that kept me up until God knows what time on Monday night, Tuesday morning on Discord. What time did we finish? 1:30, 2 o'clock?
Quite a bit later than I planned to leave.
So thank you guys for taking my mind off it on Monday night. Oh, look!
Let's just say that the 10 minutes turned into like 4 hours.
Hello!
Well, it's our attempt to
Evening, Mrs. OSK.
Hello. Yeah, it was only meant to be a half an hour chat on Discord that turned into a full-blown Marvel dissection, DC dissection. What else did we talk about? Oh dear.
Quantum physics.
Oh yeah, we talked to quantum physics. How did we get to quantum physics? I don't know. Well, it was a superposition.
6502. He's quite an interesting character.
Yeah. Yes. Yeah, it was only meant to be on for half an hour or so. Yeah, we talked about quantum entanglement, superpositioning. We probably solved a couple of physics mysteries as well. We may have invented warp drive, I don't know. But anyway, so I had all weekend to prepare myself. So I was in a better place than I was after Nico passed. thanks to Mrs. OSK and thanks to you guys in the evening. So yeah, so I thought I would do a stream just to try get back to normality. But like I say, once I pick Aston up next week, I've already got his place laid out next to Nico. All I can think is Nico was waiting for him, and then when he got up there, Nico went and said, "Right, guys, right then, shall we cause some trouble?" And then he sits on his head. So yeah. Anyway, so I just wanted to show a couple of things because we've had some things sent to us, and I've got to show it because it's only fair, and I think it's brilliant. So here we go. Mrs. OSK knows about this. I've got to find them now. I don't know where I put them. Hang on. Where did I put them? Oh, here we go. Someone sent me this. I bet you can't.
Excellent, what?
I bet you can't guess who it was. But what a brilliant C64 piece of artwork. Absolutely brilliant. So as well as we've got Nico in C64 artwork, we've now got Aston. So I'll be doing a stream trying to port that onto, whoops, can't see it I don't think, onto that up there. So I can have Aston and Nico side by side when it comes to their memorial. But yeah, it's SP. You are a genius. I wish I had this artistic flair than my stick graphics. But yeah, absolutely brilliant. So he's been immortalised in a C64 just like Nico. Never again will two dogs make such a big impact, I think. But yeah, tar very much, matey. Right, am I allowed to show what you did for me? What you've showed me yesterday?
Yes, no worries, mate.
You sure? Which one?
Yeah, no problem.
Which one?
Either one, doesn't matter. Take your pick.
Alright, so someone has been trying to make some artwork for the cover. And so this was the first thing he sent me. So this is potentially artwork for the book cover. Yeah. Hey Warlock. So there's that, and then he sent me this. So you got to imagine that it's going to be wrapped around. I think they're excellent. And it's an integrated circuit cityscape. That's how it looks. So we're getting there with some artwork for the book. I do like that one. I do like the second one. So yeah. Anyway, so that's what happened this weekend. So if I croak a little bit, you'll understand. But I thought we'd have something different as part of the Christmas period, is to try and make a as part of the book, right, we want to do what we want to. Part of the book, we want to do what and basically copy Derek's style is to provide. So when people get the book, they can download a zip file with all the tools and stuff and the tutorials and the examples. And what I want to do is I want to write a 6502 emulator stroke debugger, so we don't have to use the C64 debugger, yeah? Because the C64 debugger I think is way too complex for the noob, and I want to make a C64 emulator stroke debugger that is simple, straightforward, and works on all operating systems, right? So the fact that it's got to work on all operating systems means it's going to be .NET Core, and obviously I'm going to write it in C#, yeah? So as you can see, I've made a start, yeah? So what I'm going to do is I'm going to run through my thought processes on and where we've got so far, and then for the streams running up to Christmas, we will do the homework stream, by the way. I haven't forgotten. We will do that homework stream, and then I'll set the next homework for it.
Good, because I spent forever on that.
No, we are going to do it because I've got to do the big scroller as well. Won't be as big as Protons, but there we go. But we'll do the big scroller because I want to add the functionality to interrogate the character ROM, yeah? So we can put big characters on the screen and then make it a custom ROM. So we need to find a custom ROM somewhere, a custom character set that we can use for it as well. So we will do that, but this is going to be the sort of Christmassy thing, streams. One, it means that people are learning C++. I know GaryMeg says he doesn't want to learn sorry, not C++. I know Gary doesn't want to learn C#, but it's C++ in disguise. It's C++ in disguise, mate. So you should be able to pick this up straight away. But it's to also ask you guys about how to do things, just in case I go down a rabbit hole and I shouldn't do, because I tend to do that sometimes. So what I've done is I've started the project off, and
Hi, John here. Another subscriber. Stay a while. Stay forever.
hey Gary, thanks for the subscription, mate. 22 months. Oh my god. You don't get that for GBH, do you? So here we go. So I'm going to fire up Visual Studio Code for this. Yeah. I know you're going there, but I don't. By the way, do you like the new chat overlay? By the way, bet no one's seen it, have they? That it actually scrolls up. Yeah, it scrolls up. With the help of 6502 Kebab. Many thanks to him. And also for Gary for getting 80% there. Gary had done 80% of the work and then couldn't quite figure out how to do the final bit. And that's when he dragged me into it. And then I couldn't do it. And then that's when 6502 came into the picture. Right. So what I've done is I've tried to map this out. Yeah, I've tried to map out the core aspects of a 6502. Can you see the diagram, by the way? Do I need to make it any bigger? Yeah. If you can see it, if you can't, let me know.
Okay for me.
Right, okay. If it's okay for you. So, what I've done is try to take the core aspects and Andy's the one who struggles. So trying to take the core aspects of the 6502, yeah. So we have memory, we have registers. One of them is the status register. We have an instruction. We have the collection of instructions, which is the instruction set, and then we have the CPU, which ties it all together. So what I've got a class that I've called memory bus, right? And this class is basically going to hold all the memory information. Well, basically all the program, yeah. Your nose is touching the screen, so no problem. So the memory bus is going to contain all the data that's in the 64K of RAM, yeah? We have got a status class, which is basically the individual statuses as Boolean, yeah? So we've got the negative flag, the overflow flag, we've got the decimal flag, interrupt, clear, blah, blah, blah. And then we have I've got another one called status register that constitutes all those Booleans into the official 8-bit register. And then that is used by the registers class, which controls the accumulator, the X, Y, the program counter, the stack register, and the the stack pointer and the status register. And that's what this arrow means here. It's saying that this class uses this class inside it. Yeah. So if anybody doesn't know UML, that's what it means, and that's why it's got the word use. This class is using this. Yeah. So you've got to imagine that the way I was taught at university was this class is sucking the functionality of that class, so it's pulling all the functionality into here. Hence why the arrow goes that way. Yeah. Same with the memory into the CPU. That the CPU uses the functionality of the memory, so it uses it. This class sucks. And same with the instruction. So we've got an instruction class, and the instruction class is going to have the operator, the addressing mode, what the opcode is, how many bytes and how many cycles. I put the number of cycles in there just in case I wanted to emulate the cycles, but I think that's just going slightly above and beyond what the noob needs to know. And then we've got the instruction set, which is a collection of instructions, yeah. And so that class is going to be able to represent the current instruction physically for the user. So it'll do the assembly line and stuff like that. And then we got the CPU class, which is basically it will emulate the booting cycle. It's going to emulate the execution cycle, and also it's going to do a disassemble of the next instruction because of what I want to do. So now you've seen these classes, yeah? If I open up the class, you'll see that I've created the classes based on the diagram. So we'll start with the status. We'll start with the status class. So here we go. Oh, small letters. Let me go back to this one. So we'll start with the status class. Here we go. So we've just got a class with Boolean variables in it. So these are private, so they're internal. And then I've exposed them using properties like this. Yeah. And the only reason I've done that is it allows us to have a little bit of control. And I wasn't too sure if I was going to have to write some code in some of them to do any jiggery pokery. But then we've got this status register property here, which builds up the official 8-bit register. So it takes all the flags and builds it up into an 8-bit byte and then spits that out. Yeah. So we can still, out of the class, get the official layout of how the status register would look in the 64. So we've got registers class. So dead easy. Status register, stack pointer, nothing special, and we've got we've got a constructor class that sets the default. So the default would be 0, 0, 0, FF for the stack pointer, 0 for the program counter, and the status register are all set to false. As far as I understood when I was reading the book. Then we've got the instruction. So this is the instruction. So we've got some properties. So we've got an operator. Now the operator is LDA, right? STA, LSR. It's the text that we recognize that instruction by. The addressing mode is basically the addressing mode. So which one is it? Is it absolute, 0 page, 0 page X, 0 page Y, all that jazz. So we know what the addressing mode is. The opcode, that's the actual binary value of the instruction. How many bytes it takes and how many cycles. But like I say, I don't think I'm going to be going there. And then we've got a constructor to build it, and then how it represents this instruction to the user, how it represents. So basically, if we do an operator.toString, as long as we pass in the address and the operand, because they're two things we won't know because they're the following bytes or the bytes after or whatever, yeah. So we have to put it in there and then send the next byte or two in that and what the current address is, yeah. Now if we don't send the address, it'll automatically assume 0, and then it represents that instruction as a user thing. So it would say LDA, so for immediate mode would be $$ and then the operand. And so it's a way of being able to get the instruction class to be responsible for displaying it in the correct format. Now I haven't tested this yet, so there's going to be a lot of jiggery pokery because it's bound to be wrong. It's bound to be wrong. Then we got the instruction set, which is basically the collection of instructions. That is basically it. So I've put a couple of commands in functions in here. What we've got an opcode and it's been overloaded, yeah. So the first one is saying send me the mnemonic. So if anybody knows what a mnemonic means, it's LDA, STA, blah blah blah, that, and what the addressing mode is, right? And then it will do a link search over our instruction set collection to find the right one, yeah. And I've also done one for opcode, so it then scans the instruction set and looks for the opcode, the instruction with that opcode, and then returns that instruction back out. So this is basically the instruction set, and oh, that's just the collection. So that's the instruction set, and then final but not, well, I haven't done memory, have I? I did do memory. Hang on, let's do memory. So this is the memory class. So the memory class is going to store the memory state, and it's also going to store what the previous action to that memory was. So it stores what we store in memory. So LDA 01. So that'll be what, 6901. But also it will store whether we have just written to it or read from it. So I've sort of nicked it out of C64 debugger, but it's not going to be as sophisticated as a C64 debugger, but it will represent to the user that's going to read the book and run through this. So they will be able to see which bytes have been read and which bytes have been stored to when they step through each and every instruction, right? And that's one of the things that I want to get across to the people reading the book and they're running through the exercises, that they will quickly identify what is going on, because we'll get the emulator to show them. Yeah, we'll get the, and I'll give you a quick once I've talked about this, I'll give you a quick thing of what we've done so far. Yeah. So that's what these two are. One is the actual memory, which is RAM, and then we've got the RAM state, which is basically saying you have just read from this, or you have just stored something here, and we'll show that in a bit. So I've got a couple of overloads. I've got a load. So we've got a basic load, which basically says that we're going to load a binary stream into the memory, and because we haven't provided a load address, it will load it straight into 0. And I got another function that if you provide a loading address, it will load it at that address onwards. We have got a read, so this reads a memory location. All right. We have got a read word, so I've sort of cheated a bit because I don't want to do 2 reads. So I've got read and read word, which effectively does the same. We're not trying to simulate. I don't know which is the right word. Is it emulate or simulate? Is simulate simulation, and emulation is what it's supposed to do? I get confused. Which is the right word? I think it's simulate. Hang on. Have I lost people out of Discord?
Don't know. Have you?
Oh, you're still there. Is it emulate or simulate?
I would have thought simulate.
No, I'm not emulating the hardware, no. Stack bats. So let's say we're simulating, yeah. So that's why I'm doing read word. So it still gets the 2 bytes, but it's just doing it. And then I've got a write. So we're not writing a word. We will be writing bytes, yeah, because that's how we're simulating. And then I've got these observes, right? Now these observes basically looks at the RAM for the display purposes, not for the simulator purposes. So what I don't want to do is when I'm reading the RAM to display on the screen, I don't want it to affect the RAM state, because when I first did it, right, everything turned blue because I read everything, and I went no. So I've had to write these other functions called observe, yeah, that allow us to look at what the value is in the RAM without affecting the RAM state. Because it was just all blue. Because I just read the block and it was all blue. And I went, uh-oh, no. So we've got this observe, and these observes are purely for the user interface. Yeah? Because we're observing the memory. We're not actually interacting with it as the CPU would do. And then I've got the 6502. So this is where all the execution stuff is. I mean, it's absolute it's absolute pandemonium. So we've got the boots. So basically,
do you do the same thing with like status register, so you can flag when a bit's changed?
Yeah, that's what we're going to be doing today. Because I haven't done that yet. So that's what we're going to be doing today. So the 6502, when it fires up, it goes and reads memory locations FFFC and FFFD, and whatever's contained in those 2 bytes gets plonked into the program counter, and then the chip goes, yeah, from that point. So that's what this boot's all about here. So it's going to boot from the memory address of that and sets the program counter, which is what this does here, yeah? And that's all it does. We're not going to run it because the whole point of it is a debugger, right? So my whole concept is when this debugger fires up, right, it will be on the first instruction, waiting for the user to interact with the simulator. And then as they're reading the book, they can do what it says in the book and follow along. So it's not going to run. I haven't decided whether to put a run in there, but I don't see the point, since we're trying to teach the reader how all these instructions work. Yeah, we've got a disassemble, which actually does the disassemble of an instruction, and I think it's the next one. It looks at the next instruction. We've got a disassemble at, so if we give it a memory address, it will give us what it thinks it is. And then we've got execute next instruction, which is going to perform the execution of that instruction. So we get the opcode, and then it's a massive switch statement. Massive switch statement. So here we go. So let's start. So this is, just to give you an idea, this is add with carry. Yeah. That. Oh, it's a bit further on as well, down to there. So these are all the opcodes for add with carry. Yeah, so I've grouped them all together. This is what add with carry normally does. So accumulator plus memory plus carry goes into the accumulator and carry. Yeah. And we set these flags. So this is what's happening. So we test for whether we're in decimal mode, because that's it, that operates slightly different. And we perform the decimal add. But if it's not in decimal mode, it does the normal add with carry. Now the reason I've called this a function is because we use it in a few other places. Yeah. So if I just go to definition, there you go, add with carry. That's basically what it does. So the answer is register A plus what we send in. If the carry's true, then we add 1 to the answer, and then we evaluate the registers of the answer, and then we do the overflow test, which is that, which I read in the book and I was going, really, is that what that does? But apparently it does. So yeah, God knows why. And then the A register is the answer. Yeah. So that's add with carry, and it does it, and because, hang on, let's get back up there. Here we go. And because this operand was got here, yeah. And I've got a function called get operand, and what that does is it looks at the addressing mode of the instruction we've just got. Yeah, it looks at the addressing mode of the instruction we've just got, and then performs that address that mode. So if I go to find get operand, so here we go. So we send in the addressing mode. I've put in the cross page boundary test in there. But then, you know, I don't think we're going to get that far, yeah? If we're just trying to explain what the instructions are. I don't think we need to go into detail that, you know, when you do a 0 page comma X, for example. So if you do LDA F0 comma X, yeah, that if X is bigger than 16, it wraps back round to 0. Yeah, I don't think we need to explain that at the very noob level. Yeah, we just need to get the concept across that it's LDA whatever the value you've got in there. So say 10. If your X registers 16, then you add 16 to 10, and then it reads that memory spot. I don't think we need to confuse them at the moment with the fact that, you know, if it crosses that magic FF number, it doesn't go, oh, I'm going to look at 01 or 0101. It looks at 01 because it crosses the page bound. We're not going to go there, yeah? We're not going to go there. I don't think it's necessary. But I've put it in here just in case if we do another book, which advanced techniques or something like that, then we'll have to explain, you know, the page boundary issue and stuff like that. So this get operand, basically, we pass in the addressing mode, and this gets sent back out. This gets sent back out. So it's a flag that we send back out, yeah? Because we're already returning something already. So this is an outbound parameter, not an inbound parameter. And the end result of get operand is get the operand, yeah? So for an accumulator operand, it's just going to return back what's in the accumulator. So if it's just LSR, it's going to return back the accumulator. For an absolute, it looks at the memory location of the program counter +1, yeah? So it looks at the word, so it reads the word of the program counter +1. Then it does a read of that memory location, and that's what it returns back, yeah? And same with all the others. So absolute X does the same as absolute. The only difference is it's adding the X register to the memory location. Same with Y. And then we've got the immediate, which is just going to read the next byte as the implied doesn't do anything. Returns, it's implied. There's no operand or anything like that. Indirect, same thing again. We read the next 2 bytes as a word, and then we read that location. Yeah, indirect X. Now, indirect X is slightly different because this is the 0 page indirect X, where you read the following byte, yeah, and then you add the X to it. Same thing. This is where we would test for the page boundary. Now, I've just thought we haven't coded for that, so that needs to go in there. That needs to go in there. So that is something I need to make a note of. Hang on. In fact, we can do that now. Sod it. Do that now. So let's do this. So this is doing the memory location. Right. So and no, it's not that. That should do it. That should do it. Then, you know, in here we would do this if memory location is greater than OF. If it's greater than that, do that, and then, oh, what did I call the parameter? Cross boundary. Like so. There we go. That's the sort of thing that we need to do. So we still need it to reflect what it does. We just need to put it in. And the indirect, I think the indirect's the same, isn't it? Where's the indirect? Did we have a problem with this indirect? Yes, we did, didn't we? I'm trying to remember now. I'll look back. I'll look back because the indirect jump had a problem across the page boundary, didn't it?
Yeah, if the address is across a page boundary, it does not like it.
Yeah. Yeah, it's yeah.
But that's more a programming issue than a yeah, because you've still got to do the same thing. You've got to loop round within the page.
Yeah, I've just
to behave properly.
Yeah, I've just put a comment in there because this reacts differently, yeah? Because what happens is if the program counters at FE and it looks at FF for the low, it doesn't look at the next page for the high, it goes back to 0. So I've got to do that read word. I've got to do the read word differently. I might do that in a minute. Right, so indirect X, that doesn't have a page boundary issue, but that, you know, same thing. Reads the address, then reads the word of the memory location that we've just acquired. Oh, hang on, I think that's wrong. Hang on. Yeah, that's wrong. That is wrong. Good job I'm looking at this. That is that. No, it isn't. Hello. Hang on. So it reads the word. Right, okay, so it reads the memory location. No, it is right. What am I thinking? I was right. Put it back, put it back. It reads the memory location. Oh, hang on. I'm getting myself a bit confused here. Hang on. See, I've even put my own command. I've even put the comments in here. Right, am I actually doing that? Reads the next location, so say 2, so LDA 2, comma Y. So then we need to read, yes, right, we need to read the memory location to get its memory location.
Then add the Y.
But no, because this is, so that's just read. That's just read. Oh, the what's in. Oh, hang on. Let's write this down, right? So if we have LDA, I'll have to look at the one above it as well, just to make sure. O2, comma Y, right? So basically that reads the word from O2
and O3.
Then, yeah, that's why I put word, mate. That's why I put word. So I'll do that just to make sure. So it reads the word from O2, O3, then reads, then adds Y, then reads that mem location. That's what it does, right? So we read the O2, so that's what we do there. This is what that line does there. So we read the O2, so then we need to read the word from that memory location, right? Okay, so this is not this is a new memory location, so it's not operand. I'll just overwrite the memory location again. So we read the memory location we've just read, which is O2. So we read that memory location, which is O2 and O3. We store it back in there, then we do the read word. Right. So then we do the read word. So operand equals memory read memory location plus registers dot y. So that's the memory location plus the y. That's it. That works. That's right. So have I got this right? So we read the memory location. And then we add the X to it, and then we read that memory location. Yeah, that's right. That one's right. Yeah, that was wrong. Good job on checking this, isn't it? Relative is doing a signed extension of the next one, so that works out whether it's going backwards or forwards. I've got a function to do that. Read 0 page, obvious. Read 0 page X, so that's reading the 0 page value plus X. So we've got to do, oh, see? I worked it out differently there, look. Yeah, I worked it out differently. See, 2 different days, 2 different days, 2 different ways of doing it. But I haven't set the cross boundary here. I haven't set the cross boundary. And then we've got push byte, push word. So that's basically pushing onto the stack, popping byte and popping word. So that's the what's that message up there? Go away. So that's that. So at the moment in the program we do this, right? So ignore that. So I create a new instance of the CPU. I then populate the memory with some details. So I do a write. I do a write in memory in byte memory location 1 with FF, and then I do a read of byte 3, and then this is doing creating some blocks in the thing. So if I run it, this is what I've got so far. There you go. So because I did a write to this memory location, it's turned it red. And because I did a read from this memory location, it's turned it blue. Now what will happen is when we do the next instruction, if I don't read from there, it should disappear. But I haven't done that yet, so we'll need to do that, because I want it to show it, and then I want it to clear out. Yeah, I want it to go away, so it shows the next instruction which bit is affected when. So what I was thinking was, so this is the first half of the 0 page memory. This is the top of the stack memory. I wanted to put the register status somewhere here, and then here would be the disassembly view that would show our current location and the instructions next and the instructions that have gone past. Yeah. So that's some other functionality that's not emulated within, not simulated for the 6502. It's just basically to put it on the screen. And then down here at the bottom, we'll have a memory view that the user can specify. So if the user wants to look at memory block 1000, then as a parameter, we're going to have a parameter that they can send in that will show memory block 1000 down here, so they can see that memory block if they wanted to do it. So by default it will be set to 0, because 0, unless we think of a better location to default it to. But that's the sort of concept. So what do you think? Do you think how it will work? So down here will be the menus, yeah? So down here will be the menus like next and stuff like that. So if they want to change this menu block, we can allow them to change it. But this is what I want to try and do. and it's for the guys that are struggling to learn 6502. I want to go through each of the instructions and how they work, but I also want to visually show it do it. So if, like here, if the instruction was STA01, FF, it would have put a red FF there. And same if there was a LDA 03, then it would have turned that blue. So they could see exactly what memory's been affected. And same with the status register, which is what we're going to do is when the status changes, we're going to get it to change colour. So if the carry was set, we'll get it set to red. Yeah. If it didn't get changed, then we'll make it go back to white and stuff like that. So that's the sort of thing I am trying to achieve, for a better word. And I was supposed to do the registers on Monday, but we got sort of distracted with quantum physics and Marvel and DC and stuff. Sidetracked, yeah. I didn't write one line of code on Monday, which is not what I was intending. Anyway.
So you've actually improved on the first Discord evening then?
What, with just that one line of code?
Yeah.
Yeah. Yeah. So,
well, blame 6502.
Blame 6502, yeah. I mean,
he's not here tonight, is he?
Well, I don't know, but I mean, you know, he took my mind off it, which is, you know,
yeah.
He took my mind off it, which is what was required. Right. So, what you've seen so far, do you think I'm on the right track so far?
It'll work.
Well, this is what, you know, you are my target audience, mate. Same with stack bats. Hey, Godspeed. I didn't know you'd come in. But that's what it's aimed for. Yeah, so that's what it's aimed for, is the people that are struggling understanding the instructions. Because I know that is a big problem for a lot of newbies, yeah? That they don't know what instructions are available to them, and two, they're not sure how the instruction actually works, especially with all the different addressing modes. That is something that people have been talking to me about, is the addressing modes. That's one of the big things. You know, when do I use an absolute or an absolute X, or when do I use a 0 page, X, or 0 page, Y, and that sort of thing. So yeah.
And why isn't my code working? Oh, it's because I forgot to tell you it's an absolute number, not a bleeding address.
Exactly.
I don't know how many times I made that mistake.
Well,
I thought it was because you didn't put an RTS in.
Shut up. Well,
I spent an hour on that bleeding homework, wondering why it wasn't doing what I wanted it to do, and I'd missed one absolute.
Dude, I have done it many times on stream, and we've laughed about it. I knew the RTS would appear. Even if you don't reference the instruction cycled counter directly, are you still going to include it in the disassembly?
I don't think it's needed.
Yeah, I mean,
it'll be a distraction more than anything. If there's a number there and people are going, "What's this for?"
Exactly. That's that's why
there's a toggle that you can toggle on and off.
Oh, I don't want to.
work.
I don't want to put settings in there, mate. Come on. Well, hang on. Let me rephrase that. for this project, I don't think we need to do it. For if we do another book where we raise the level again, then when we come to redo this debugger, then yeah, we could do that sort of thing where we have settings that simulate the cycles and stuff. I just think at the moment, feature creep. Have you ever heard of feature creep?
Oh yes.
I'm trying to avoid feature creep.
Yeah, I think that's the right way to do it. You've got it built in there, but keep it hidden for now. And if you do a book 2, advanced, whatever, then expose it then.
Yeah. So I'm hoping that also people will use the debugger for other things, you know, just basic 6502 debugging and stuff like that. So, right, registers. Oh, hang on. Who's pinging me now? Oh. Tail. Oh, well, I've just subscribed to somebody. Who have I just subscribed to? Hang on. Hang on. Who have I auto-subscribed to? Hang on. Hang on. Oh. Why doesn't it tell you? Oh, it does. Oh! It's Mrs. OSK. Oh dear. Is it? Oh yeah, it's 30th, isn't it? Right. Right, registers. So, what we're going to do is, in the register, we're going to have, as well as we've got the register, we'll have another one that... Oh, 6 more hostages have been released. Right, I'm going to put that on silent because that's getting a bit annoying.
Professionalism.
Professionalism. Since when have I been a professional?
should have been turned off before the stream started.
Oh. I mean, I turned it off when I went to the cinema. Oh, yeah, we went to the cinema yesterday. We saw Napoleon. Absolutely fascinating. Really good film if you ever want to see it. Right. So, how am I going to do...
You know Gary's going to text you now just to make it go off again.
Well, it's on silent now, so it won't. Well, it better not. Right, how are we going to do this? How are we going to do this? So... Right, for the memory, I did a second array. Now, yes. We'll need some private. Oh, can I do it like that? I don't know. See, I don't want to do the stack pointer or the program counter because they'll always be blue or red for the stack pointer because it's always changing, isn't it? We don't read the stack pointer really, but we can definitely do it for the accumulator, the X and the Y. And we'll have to change them into proper things. So let's do this. So let's get a region in here. Variables. Right, so we need private byte Yeah. X, Y, SP. No, I'm not going to do Word. I'll do the I'll do the stat pointer, but I won't do the program counter. And the status register. I'm going to do the status register. Right. So these need to be changed now, because what I'm going to do is we're going to have tangent PLP read write status register. Yeah. That's why I'm putting the status register in there, yeah? Yeah. Right, so let's build these out. So let's do this. That. Oh, what you complaining about now? Oh, not all code returns value. Yeah, I know that. Right, so return register A. Register A equals value. So let's grab all of that. No, just that bit, just that bit. Right, so that's going to be register X and Y. So now we can start, and I think we still use the console color. Right, console color. That's what we need. Oops, cool, full fingers and thumbs. Right, private console color, red, right, hey, Proton, no, not, no scroller today. No scroller today. We are building a simulator for the 6502. SP. Now the status register. How we're going to do that? What are you complaining about? Oh. Let's make this console color. Is the colors in there? Ew. Right, we'll have to set them. We'll have to set them down here. I'll do that in a bit. Right. So we got the console color for the registers. So the status register is going to be a different animal. So How am I gonna do that? How? I'll think of that in a minute. Right. So what we're going to do is when we read the accumulator, so we'll set the register a state to equal console color dot blue. I think that's the color I picked. So we need to put that in all of them. And for the right, set it to red. Now, what do I need? Which is something I need to put in the memory bus because I'm not too sure. Hang on, let me just do a read. Let me just look at what I've done. Read sets the color. Write sets the color. Observe. Oh, here we go. Right, observe. Right, it's observe that puts the colour back to... Right. Okay. So I need to put this in... I need to put that in the registers as well. And we will pile on that, but I think the observed colour is going to have to be register independent. Or do I really want to have... Well, it's only 4, isn't it? Yeah, okay. So we're going to be saying observe a colour like that. So the console colour equals register a state. Then we set that to be back to black. So once we've read the colour, we reset it. And then we return the colour. Right, so I need to do that for the 4. So we've got X, Y, SP. I haven't done SP, have I? No. Right. Let's grab that. Why are you complaining? Oh, I've got rid of the other one, haven't I? Right, so that's SP. 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 Right, so we're not doing the program counter because it's always changing, so we can't see the point in doing that. And we have now got a new status register, so let's get that put in there. But I don't know how we're going to tackle that yet. But let's do the basics first. So rem that out, and return. Oh, I called it status register. And status register equals value. Right. So we need to think how we're going to do this. To be honest, I don't think we're going to be able to do it in there. I think we're going to have to do it in the status register. So where's the status register? There we go. Come here. Oh, sorry, status. That's the one I want. So we've got it already there. So we just need to put the just need to do the private console color. State. That should do it. Right. So negative overflow decimal interrupt, and I think I spelt it right, and if I haven't, tough.
You have.
I'm going to say if I haven't, tough. Carry and break. Right. So, so when we read it, well, I'm just wondering, do we? I think we just should highlight it when it's changed, yeah? Don't you think?
Yeah, that's what I was thinking.
Yeah.
Just if it's changed state.
Yeah, if it's changed state, let's just do it then. Right, negative flag state equals console color dot red.
So you don't read it as such.
No. Overflow. Decimal.
Although you're doing effectively, like with add carry and subtract carry, you do read the carry bit, but I don't think it's worth messing about.
No, because
just those odd bits.
Yeah, because we add the carry, but then we immediately set the carry, because when you add the carry, it goes to 0, doesn't it?
Yep.
So therefore, we're right into it, and that's why I was thinking. Yeah, I think it's not really worth it, because you wouldn't actually see it if it was in the same operation. Break. Right, so have we got a constructor? Yes, we do. Right, okay. Negative flag equals console dot black. Yeah, you can overflow flag. Yeah, I like this. Come on, how to code quickly. Choose one, GS or DD. If you're gonna wonder why, you'll see the what and how after you've selected. Also has nothing to do with coding. I am not sure what you mean there, Kylo Dos. GS or DD? All right, so I've got to pick one, GS or DD. Without knowing any context. All right, then. Where's my coin flip? Where's my coin flip at?
Ask Alexa or Google, whichever you've got.
I think I've got a coin flip. Hang on. Yeah, I have. Here we go. Right. So, come on then. Oh. Go away. Don't show this message again. Go away. How do I get rid of you? Go away. There we go. Right.
And John looks up when the channel's empty.
What? The channel's empty? Right.
Yeah, we've all gone.
No, we've all gone.
What's cooking, Doc?
What, the URL?
Yeah.
Yeah.
Right. So there, coin flip at. So heads, GS.
Right.
Tails, DD. Here we go. It's gone on its end. Right. Even the phone was undecided. Right, it's heads. So that's GS. There you go. There you go. Bum, 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 ba, da, ba, da, ba, da, ba, dum, bum, bum.
Hi, John here. Another subscriber. Stay a while.
Oh, you're joking.
Stay forever.
So what was GS?
Hi,
Oh.
John here. Another subscriber. Stay a while. Stay forever.
Oh, GS gifted subs. Oh, dude. How many?
Hi, John here. Another subscriber. Stay a while. Stay forever.
Oh, dude, you're bonkers. You're bad as Docster.
Hi,
Thank
John
you,
here.
by the way.
Another subscriber. Stay a while. Stay forever. Hi, John here. Another subscriber.
Docster's laughing.
Stay a while.
Right.
Stay forever.
I need to do this because the set doesn't actually go through the set.
Hi, John here. Another subscriber. Stay a while. Stay forever.
What?
Hi, John here. Another subscriber. Stay a while. Stay forever.
Oh my God, Docster, you two are bonkers.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Just out of curiosity, what was DD then?
Hi, John here. Another subscriber. Stay a while.
Oh, what
Stay
to spoil me with
forever.
a... Oh, direct donation, right. You want to
Hi,
spoil
John
me a
here.
gift Christmas present?
Another
Oh, thank you very much.
subscriber. Stay a while. Stay forever.
Who's there? Holly Pie?
Hi, John here. Another subscriber. Stay a while. Stay forever.
Oh, what?
Hi, John here. Another subscriber. Stay a while.
No, come
Stay
on.
forever.
Come on.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Guys.
Hi, John here. Another subscriber. Stay a while. stay forever.
That's going to be doing that for ages.
Hi, John here. Another subscriber. Stay a while. Stay forever.
It's very kind of you to say that, Kylodos. Very kind of you.
Hi, John here. Another subscriber.
Hey, Rick Trick's got one.
Stay a while. Stay forever.
No, I didn't miss your question, Proton. I'm just waiting for the subs to...
Hi, John here. Another subscriber. Stay a while. Stay forever. Hi, John here. Another subscriber. Stay
LB Neo's got one.
Stay forever.
God, dear. And he doesn't even code. Right. How far?
Hi, John here.
How far?
Another subscriber. Stay a while.
God.
Stay forever.
We're still in Docsters. Back in a few. All right then, Saucy. We'll see you in a bit.
Another subscriber. Stay a
Oh
while.
my God, more bits?
Stay forever.
Thank you very much. You guys really spoil me. Oh.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Mrs. OSK went and told me that I need to keep it as biscuits because now instead of buying
Hi,
the boys
Johnny.
biscuits, you buy
Another
me biscuits.
subscriber. Stay a while. Stay forever. Hi, John here.
Are we still
Another
going?
subscriber.
Are
Stay
we
a
still
while.
going?
Stay
So
forever.
they'll still be going when Saucy gets back.
Yeah.
Hi, John here.
It's very
Another
kind of you
subscriber.
two, especially
Stay a
with what
while.
I've just gone through
Stay
this weekend.
forever.
It's very kind of you. I'm trying not to
Hi,
blubber
Johnny.
on camera like I did
Another
before.
subscriber. Stay a while. Stay forever.
I keep
Hi,
looking.
Johnny.
I keep looking down there.
Another subscriber. Stay a while. Stay forever. Hi, John here. Another subscriber. Stay a while. Stay forever.
You'll have to borrow Mrs. OSK's little dog.
Mrs. OSK had to
Hi,
let
Johnny.
Barney go.
Another subscriber.
Oh, was she?
Stay a while. Stay forever.
Yeah.
I see it on a thing like I didn't realise she'd had to let it go.
Yeah, she had to let it go. She's
Hi, Johnny.
given to a family
Another subscriber.
that they'll be
Stay
able
a
to look
while.
after him.
Stay forever.
She with all the hours she was working, it was unfair. It was unfair. So unfortunately, Barney's with another family now. But I keep looking there. It's I've just done it because I thought, oh, I can't hear him, and I've just looked and I've just seen the candle, and I thought, ugh. It's going to take a while for me to get out of that habit, isn't it? Right. Proton. Yes, we are building a simulator, and the reason we're building a simulator is for the book that we're writing, yeah? Now, you've just asked what's wrong with Vice. Vice is a C64 emulator, and I don't want Vice involved. I don't want C64 debugger involved. All I want to do is write a small console app that will simulate the 6502. So when we write the book about the instructions, yeah, when we write the book about the instructions, this simple simulator will help them understand the instructions. Yeah. Alright, so that's why we're doing it. It's not that Vice is not a good debugger. I just think for a noob, you know, it'd probably be a bit too much. So we're just trying to teach them what all the instructions do. That's why we're emulating the registers and the status registers and all that. We're not doing cycles. We're just concentrating on what is LDA #0. Yeah. How does that work? What is ASL? How does that work? Yeah. So we're just writing a very simple console application that will work on the 3 operating systems. So when we do all the examples and use VS Code to do it with Kick, they will be able to send it to this. Send it to this. I forgot to turn the work phone off, didn't I? Shut up, work phone. All right. So yeah, that's why we're doing this. Right. So where was I before the kind donations of gift subs? Vice is just too much for a noob. Vice is too much for a noob. All right. Just too much. It's got to be simple and straightforward for a person who's not 6502 adept. We don't want to have to worry about the 64 and the structure of the 64. Just concentrate on the 6502. Right. Right. So we need to, so I've initialized the colors on everything. We've set that right. So we need the observes. We need to be able to observe those. So what we're going to do is we will grab this and we'll just hack it to bits. Grab that and hack it to bits. Right. So this is console color. Observe negative flag. That's what we need to do. And then return negative flag state. So it's only read only. But we need to do the thingy. Right, hang on. So console color equals negative flag. Right, and then negative flag state equals console color dot black. And then we get rid of that. So we don't need that, and we don't need that. That'll do. That'll do. So this is overflow. Right. So decimal. Go. That's that one done. Interrupt. Ooh, that's not how you spell it. 1p. No, mate, didn't find any suitable ones. That's why I'm writing one. I did look, I did do the research. Couldn't find one that satisfied my requirements for the book. And, you know, gives us a chance to learn C# while we're at it. I think it's more fun to write as own. I mean, we're not going to be emulating the 6502 with the cycles or anything like that. We are just simulating it to do what we want in a nice, easy, straightforward manner for the noob. And I say that with much affection. I tell you something, I wish I had this sort of stuff when I was a kid. Right, so that's doing the observe. Hey D-Type, welcome. Welcome. Right, so that's the observe. So now we can observe the status flags when we put them on the screen. So that should be okay now. So we do a new status register. Right, okay. Have I got, do I set everything to false? Because if I don't, I'm going to do it. Right. Underscore negative equals false. Right, underscore overflow equals false. Decimal equals false. Come on, visual. Yeah, that's it. Write my code for me. This is what I like to see. There we go. There we go. Writes my code for me. Right. So that's that done.
You programmers have got it fairly easy, really, haven't you?
Well, this is why Visual Studio. This is why Visual Studio is expensive, yeah. But this is the community edition, so even the community edition does this. I mean, we could write it in VS Code. I mean, VS Code does a very good job of it if you download the Microsoft C# extensions. It tries to do the same sort of thing.
And I'm back. It's
hey,
cold out.
Hello back. Yeah, so the gift subs have subsided, and we all got a level 3 train choo-choo emote, I think. Right, so that is that. Brass Monkey, yes, it is Brass Monkey's outside. I've got my heat pad on behind me. Right, hang on. Alexa, what's the house temperature? Did you hear that?
No.
Hang on. Here we go. Right, here we go. This is how warm it is in my house. Come on. Hello? Alexa, what's the temperature in the house?
The house temperature is 13.3 degrees.
Did you hear that?
Really?
Did you hear that, boys and girls?
I did. You want to invest into insulation.
It's
Are you,
bit nippy.
you in competition with Big Clive on YouTube by any chance?
Why? What's Big Clive do?
He doesn't have any heating on either.
Yeah, but then he works in a basement.
Yeah.
Well, I mean, the central heating was on this morning because the house was 9.9, and I thought I've got to put the central heating on. It's not true what they say about Yorkshire chaps and money. Oh dear. Yeah. I mean, I've got my heat pad behind me, keeping me nice and warm. And because it's all coming from the battery, it costs me nothing. I like it when it costs me nothing. Right.
Honestly, it costs a fortune to heat a whole house, and you're only ever in one bloody room.
Well, this is it. This is it. But, yeah, when it gets below 10 degrees, I think, I better turn the central heating on. Especially when you see icicles inside the house.
It's a long time since I've seen them.
What, icicles inside the house?
Yeah, the glass frozen up on the inside.
Yeah. Right. Well, I wrote a 6502 emulator in 2002 in 4th. Oh, very impressive. In the middle of the desert in Yemen. Next step was to make it into a Centipede emulator, but it's now on the back burner. Yeah, like everything else, mate. I've got loads of back burner projects. Loads. It's just because I get bored after a while. Well, that's the beauty of back burner projects. You can go back to them.
But the biggest problem is remembering what you did in the first place.
Yeah. Well, that's where documentation comes into it. Light a candle. I've got a candle lit down there, mate. And it's such a nice... let's change the colour.
That's why it's 13.3 and not 13.1.
Right.
All the heat off the electric candle.
Yeah. Right, let's change the colour. There we go. I don't know if you can see that colour change. Can you see the
Not
colour?
really. It's a bit.
Yeah, you can. The bed light lit up blue now.
Oops, wrong camera view. That one. Yeah, it's blue. Look, can you see? It's blue. Yeah. Good old Aston. I've got to reduce the camera's... I've tried to reduce the camera brightness. Hang on, let's try again. That one.
No, like Gary says, you can tell because it lights up inside the bed.
Yeah. Let's see, configure video. I'm going to turn the brightness down. There you go. Well, that's not doing anything.
That's just switch the lights off in the room.
Hey, that'll be really bright then, won't it? Let's do that. Let's just leave it like that. Contrast. Well, it goes a bit white, doesn't it? Yeah. I need a better camera, that's what I need. I need a better camera. There's only one automatic setting on here, and that's white balance. That's stupid. Maybe I need to change the flicker. Nah. I don't know. I don't know. Oh, maybe the exposure. There we go. How's that?
Oh, yeah.
There you go. Where's where's Aston? Yes. Unfortunately, Proton, Mrs. OSK and myself lost Aston on Monday. He passed away on Monday. So that's why Aston's not there. Hence the candle in his bed. Contrast, he said. Contrast, hang on. There you go. You can see his bed now. You can see his bed now. Yes, we lost him on Monday. He was 18 and 7 weeks. I think, yeah.
That's an impressive age for any dog, John.
Yeah. Yeah. The thing was, I was editing the videos to earlier on, and it was October. It was the October the 2nd and October the 4th videos, and he was wandering around quite happily. Fine, he was a bit wobbly on his feet, but he was there being a pain up the backside, and it just shows you with just over a month. Yes, I've lost both dogs in a year, in less than a year. This 2023 has not been a good year. No. So yeah, but he went down quick. Anyway, so enough of talking about Aston, because it makes me slightly tearful, and I don't want to blubber on stream again. Right, I've forgotten what I was doing. Anybody remind me what I was doing? I set the state.
Well, I'm going to have to call it a night anyway, chaps.
All right, mate. Thanks for joining anyway, mate.
That's all right. Not a problem.
Have a speak. Are you on your way back tomorrow then, are you?
I'm heading home, yes.
So where are you then?
In France at the moment.
Are you in France? What, you at the port, are you?
No, not quite tonight. Haven't made it that far.
All right, then.
But we're not doing too bad. We're 3 hours away.
All right, Stat Bats. Night, mate. Chat to you later. Early start and then the office party. All right, night, Gary. See you later.
Then I.
God, Stat Bats having the coffee's party tomorrow. God, it's all right for some, isn't it? It's all right for some. Right. So I've done the registers, and we've got the observes. Right. So so we need to build out the display for the registers. So how am I going to do that? So I might as well do what I've done before. So it's in here. So it's in the program. So all the display stuff's going to be in the program. What's he done? Some examples. 6502 no op drop. That's fourth, is it? God, that's impressive. Writing it in fourth. Yeah, but the carriage returns have disappeared. Yeah. I've forgotten what fourth looks like. I think I messed around with it on the BBC at school, but because it wasn't assembly, I didn't really pay any attention. Right, so we're going to create another one called write registers. Yeah. Right, so write register block. Register. So we don't need the start address. Don't really need the title either. In fact, we don't need any of that because it's specific. Right. So top line. So the title is registers, and so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That should be enough. That should be enough for the registers, I think. Right. Oh, I suppose I better tell it where to put it. So we'll grab this. Tell it where to put it. So we'll tell it where to put it. Right. Because we may want to move it about, yeah? Right, so we're at the top line, and now we are going to going to have to write everyone out independently, aren't we? Yes, okay. So because I didn't do it as a dictionary, never mind. Didn't want to really do it as a dictionary. Anyway, enough of that, John. Come on. Right, so let's do a quick test. So let's do this. Right, so we're going to be that, and so let's say accumulator is right. Right, we'll start with that. We'll start with that. We need to produce Does that work inside console app? Do we know? Ooh, it could do. Did I call it CPU? Yes. Right, get rid of that. So, y plus 1. So, let's see. Right, I'm going to rem this out. I'm going to rem this out because I just... Ooh, oh, I forgot. It's that. Because I just want to see it being done, right? So, let's just do this. So, do that. And we are going to be... 50, and we said it was, so we'll do 40. So 40, comma 0. Right, let's see what we get. Oh, just a bit too far. Right, so 30. Oh, I don't know. Oh, I don't know. I think that's bang on. I've just got the wrong character. I need that. Well, that's bang on, isn't it? Get in there, John. Right. So, we need to... We don't need that. Let's get rid of that. Grab that. Because we need to set the console color now. So console dot back color equals CPU dot registers dot observe a colour. There we go. Then write that. And then I need to put it back to what it was. So, oh right, yeah. Can't have that. Put it back to what it was, and then we'll do that. Right. Let's run it. Let's see what it looks like. Come on. So it says we've written to it. Maybe we have. Did I... oh, hang on. Did I initialize it? Oh, yes. I went through that. That's why it's initialized. Right, okay. Do I need it initializing? Hang on. What have I done here? Right, I initialized the internals. Right, so we need to do the same for this as well. So, so it's register A. So register A, register X, register Y. Do I have a register PC? No. Register SP. Just register SP. And then that should take care of itself. Oh, you've got an ace on the shelf. No. They're minted, they are. Right. Is that black now? Yes. Right. So, let's go into program and let's set, right, CPU dot registers dot A equals 80. Right. Does it go red now I've set it to 80? Yes! Get in there! Ooh! Right. Right. So this needs to be made into a function. This needs to be made into a function. So let's do that. So void write register line. So we need to send in the register. So write register. Yeah, yeah, and the console color. console color. That should be. Oh. Yeah. String. Register name. Need to send that in. Right. So we should. Oh yeah. We need that as well. Why? We need that. Right then. So we just need to copy this. We just need to copy this into here, like so, and X and Y. Don't need to do that, but we need to need to build this out. I think need to build this out. Right, string line equals that plus register name plus that. Oh, I've made it a byte, haven't I? Let's do that. Oh, does it have Word? No. Oops. Right, so I need, yeah, so first things first, if, oh, that's not right, no, that's right, if register is greater than do that, else do that. Right, okay, so if the register is bigger than FF, that means it's a word. So S line plus equals dollar plus register dot toString open bracket x4 now if it's not a word we're going to do that and make that x2 and then S line plus equals that, then that can go in there now. But I've made a crucial error.
It's hard to squeeze your colour in there now.
Yeah, that's what I'm saying. I've just made a crucial error. So, right, okay, so let's move that up then. Let's move that up. So if I do that, then we can put the register name in there with the colon and forget the spaces and leave it like that, so we can get rid. So this can start off as a blank. That can start off as a blank like that, and then we'll do the thing. So we can then set the color. So we can set the color here. No. Do you think it'd be a problem if the dollar was in the colour? Nah. We are going to do it properly. So console dot write dollar. And we'll stick them in there. So that is equal to register state. Then might as well just do the console right here. And we'll do the console. We'll leave that there. We'll leave that there. Right, so we'll do the same here as well. But this time it's 2 spaces that. This is x2. Get rid of that. Get rid of that. Put it back to black. Right. We don't need that now. Don't need that. Right. So what's this saying? Is declared but never used. That's right. Okay, let's change this. So console. Let's do that. Grab that and start sticking this in there. Right. Open bracket. So accumulator, comma, CPU dot registers dot a. Oh no, observe. Oh, that's the A. Oh no, we don't set. We reset the color, don't we? Comma CPU dot registers dot observe a color, and then it's start X and start.
Hello, John here.
Y.
Thank you for following. Hope you enjoy the stream.
Klaus Ever Walking Dev, say hello. Say hello. Don't be frightened. We don't bite. Well, most of us don't. Right, that should be doing that. Hello, welcome in. Welcome to the madhouse. Oh, missing that. Docster does a bite now. Hey, that's... Oh, he's come out blue, though. He's come out blue. Right. I need to do...
Hi, John here. Another subscriber. Stay a while. Stay forever.
Kylo Doss. Oh dear. Right, we can't use this. We're gonna have to create some observes. We're gonna have to create some observes. Rats. We're gonna have to create some observes. So we'll just do this. Because we're gonna change it. So bytes. So byte observe A. Don't need that or that. Just need to return back A. Byte observe X. byte. Observe, return Y. Now, I've got a sneaky suspicion I'm doing the same problem. Hang on, register A, register, that's the one I need. Register A, register X, register Y. Right, let's get back to this. So so it's observe A. Huh? Right, so because we're because we're setting that to 80, it should be red, it shouldn't be blue. Yeah, there we go. We're back. Right, let's do the other ones. So X. Oh, that's going to be an issue. Hang on. Right, let's see if that one works. Right. Get in there. Get in there. Whoa. Right, so 3 degrees. Hang on. Hang on. Alexa, what's the temperature outside?
It's like a 0, -1.
Yeah, she says it's -2. -2 here. No wonder I've got this pad on my back. Right, so Y. So do Y. Observe Y. Y colour. Right. Oh, hang on, I forgot to add that. There we go. There we go. It's cold. Wow, it's cold bean and Englander. How is Finland warmer than here? Yeah, right. So I think now we've done that. Oh, I'll just.
Now you've got another problem.
Say again.
Now you've got another problem.
Well, hang on. I'm just going to do the stack pointer. Did I do an observe stack pointer? No, I didn't, did I? Oh, John, you muppet. Right. Stack pointer. Right, let's do that. There we go. So stack pointer, then program. Oh, yes. PC. PC. So registers.pc. Don't need that because it's a property. And we will send in black. So console color dot black. Oh. Right, that's wrong.
I told you got another problem.
Yeah. Cheers, mate.
I don't know how you're going to get around it, because unless you put the program counter to 100 or something.
Yeah. To be honest, mate, the program counter is only going to be the one that's a word, isn't it? The program counter is the only one that's going to be the word.
Yep.
There we go. There we go. So right now, how are we going to represent the registers? Zeros and ones? You think that'll be all right? Zeros and ones.
For status, yeah.
Yeah. Right. I'm thinking of putting a line here and then having the status registers below it. Yeah. I think we need some sort of separator. Maybe put a line with the word flags in it. Yeah, that's probably better. Let's do that. So let's add. In fact, we can just. Right. Let's do that. Get rid of that, then copy that. Right, so we're on 5, so this is 6. And so, flags. Right, let's just see. Oh no, that's bang on. I thought I'd gone too far. Flags, there we go. So, am I missing anything on chat? Enjoy your cold weather there. Here in Brazil, it's 30 degrees. Oh, that is just rubbing it in. That's almost as bad as Warlock rubbing it in. Oh, you lucky, lucky person, you. Hey, there he goes. Look, he's rubbing it in, look. He's rubbing it in. Shut up. Right.
Well, it's 29 over here as well.
Over where?
Here.
Is it? Where is it 29? Oh, 29 degrees F. Has somebody just worked that out?
Alright, John.
Sorry, I'm not with it. You'll have to excuse me, I'm not with it. Alright, registers. Dot. Status.
What a plank.
Shut up. Right, so observe oh, that's the colour. Oh. Oh, they're the colours. Hang on. I need to go in the status register and just check what we're doing. Oh, poo. We're going to have to do it for that as well. Rats. Okay. Let's change these to colour. Oh, that's a cobblers. We'll return a byte. We'll return the byte. So return. I've done them as underscores, haven't I? Yeah. Oh, hang on, I've done that the wrong way round, isn't it? It's that. True is 1, else 0, like that. Oh, what are you complaining about now? There you go. Sorted. What did John say about the scrolls? I haven't done them, mate. I haven't done them. We're probably on the next stream, probably. So yeah, probably on the next stream. What's next? Overflow. There we go. Let's do that. Negative, overflow, decimal. I'm just wondering if I could have done this differently. I'll think about it. I think there's probably a better way of doing this, to be honest.
Can't you enumerate it in some way?
That's what I was thinking of myself. Because I was just thinking about overloading the Boolean data type and add 2 more methods to it. That sort of thing. Oops. That's what I was thinking. Maybe overload the Boolean type for this. Then we could put all the code into the type itself and then just interact with the type. Interrupt 0. I will have a look at it. I'll think about it tomorrow. If I'm not streaming tomorrow, I might do it on Discord. Just to...
You'll not get very far if you do.
It was a good conversation. I'll quite like it. Oh, that went off, didn't it? Because I had to turn it up. Who's in the news now? Oh, Nigel Farage's girlfriend. Wow. Really, I want to really know about that. Right.
Every time I looked at the news past couple of days, somebody else has passed away.
Yeah, it's been a bit prolific, hasn't it? Observe. So what we're doing? Negative. Observe negative flag, and then here is CPU dot registers dot sr dot observe negative flag color. There we go. Who's a weirdo? Yeah, we'll get to him, mate. We'll get to him, mate. From the cold north. Right, let's see if that works. So this is negative flag. Oh, rats. Forgot. 7. Yes. That works. So next one would be overflow is next one, isn't it? So over like that. Go away. Yes. Right. What's next in the register list?
Decimal.
Let's have a look. What did I? Oops. Get up there. Right. What did I put? Oh, it's break. Next one's break, then decimal. Right. So break, then decimal. Let's do that. So we'll do BRK for break. Then decimal. Whoops. And then we have got interrupt 0 and carry. Interrupt 0 and carry. Int 0 and carry. Or carry. That's probably better, isn't it? Carry. Cry.
Cry.
Ooh. I have to think about interrupt, and I still got it wrong. This one was 0. Oh, that's easy enough to type in. And then carry. So 8, 9, 10, 11, 12, 13. And then 14. Right.
I think maybe the pluses on the end of the line with flags on the bottom one would look better as a vertical bar because it's a bit weird against the address.
Yeah. I'm just wondering if I just move it over by 1. I'm just wondering if we should make it say 39. Do that.
Oh, that's all right. It clearly separates it from the address then. And get confusing.
Crimea River. John, should you make a scroller too? Of course. If you want to have a go, dude, you'll beat us hands down, mate. You beat us hands down. But yeah, have it. Do it because anybody can have a go. We don't penalise. My back was getting cold, so I've just turned it back on again. Right. Right. So now we have to figure out how to do the disassembly. So I had a problem when I was thinking about doing the disassembly. So what I want to do is have something like this, right? So LDA $$00 STA $$00 Right, so what I wanted to do is have something like this. So it would say that's the current. So we'd have the double arrow, which indicates the instruction it's about to perform. Yeah, but what I wanted to do is to be able to disassemble backwards as well as forwards. Yeah, and the problem with disassembling backwards is we've got to figure out
instruction length.
Yeah.
Do you want the double arrow, or maybe just highlight it green or something?
Oh dear, dude, you're on form today. Right, I didn't even think about doing that.
Yeah, you've got the ability to change background colour.
Yeah. So yeah. So it's trying to figure out the instruction. So this is the rules that I was thinking of, right? So first, yeah, check 3 bytes back. Is it a valid instruction? If so, display. Yeah. Then 2, check 2 bytes back. Ditto.
What a plank.
Your instructions tell you how many bytes they are, don't they?
Yes.
Yeah, so it needs to be a valid 3 byte instruction, because you can go back 3 and get a single byte instruction.
Yeah. What was the plank for? What did I do wrong? Oh,
I think I'm just commenting on your terrible coding.
LDY. Oh, it's just an example, mate.
It was more your double laddies.
These are. It's just an example. You can't plank me on an example. And then 3, if all 3 fail, then do
What a plank.
a single byte instruction. There are many others, Warlock. There are many others. So if you do play, Oops. If you do play, there's the other ones.
What a 42 carat plonker you really are!
This one is the most. Yes, that's why it's got its own. That's why it's got its own. So that's what I would.
You numpty!
Oh, he's going to be playing them now, all isn't he? He's going to be playing them all. No, some of them don't.
Seems logical.
Yeah, sounds logical. Yeah, Warlock. Some of them don't have images, mate. We haven't found an image to display what a numpty is. to accurately display what a numpty is. It has a missing image icon, does it?
Oh, you numpty!
Oh, so it does. I'll have to have a look at that. I'll have a look at that. Another stream debugging our bot. Right.
Ah! What a plank.
Broke my minion again. I don't know. Hang on. I don't know. Well, it's definitely not in there. Yeah, it's not there. Where did we put it? Where did I put it then? Hang on. That's the one, isn't it? That's the one. Have I got that in there? Oh, it's listen. What was it? Tash the minion? Right.
Oh, you numpty.
Now it's not displaying it. I don't think it displayed it.
Oi, John, take a drink.
Oh. It was minion image dot. Okay. Like that.
Oh, you numpty.
It's still not showing it. Oh, we'll check it. I'll mess around with it later. Right then, so what we need to do. Error. Some of the other ones have them. I don't think syntax error in line you. Right, so we need to work out how we're going to do this disassembly. Now we know the program counter because we've got that. Wooga, this is not a drill. Right. So how are we going to display? So cool, looking at that light's giving me orange orange circles in my eyes now. Let's turn it down. A bit too bright. So we need to work out the line. We need to work out the lines. So we got to work backwards, haven't we? So we've got to work backwards and then forwards from our current instruction. Let's do work forwards first, because that'll probably be easier, and then we'll try and do work backwards. Right. Okay. So. So we need, right, so use short program counter. So that's the current program counter. What else do we need? Oh, we need X and Y, don't we? Right, so we need X and Y. What else do we need? I think that's it. Right then. Okay, so we're going to display the current instructions. So we need to set the console color. Oh, not black, green, 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 green. So we set the console color, and so right. So we need to set the where the point is right at. So we're gonna just put 2 spaces in. We don't need the X. We just need the Y. We don't need the X. Because I'm gonna make it. I'm not gonna have it right on the edge. So don't need the X. So the X can be 0. Well, then again, we'll put it back in. Oh, go away. Right, so that sets our point. That sets our point. And so, right then. Right, so how do you do a while loop? Is it while like that, and then number of lines is less than or equal to 5? Yeah? Is it like that? Well, it's not complaining, so it must be. Have I exposed the instruction set? It doesn't look like it, but I've got that. Right, okay, so I've got that. But that doesn't help me. I have not thought this out. Not thought this out. Not thought this out.
You have to get it to an opcode to find out how many bytes it is.
Yeah, that's why I'm doing this. Disassemble instruction bytes. Just put the same memory address in and then return this. So instruction. Return that dot number of bytes. What are you complaining about? Oh, int. There we go. Right, so we'll do the same for this as well. Which is register PC. Right, that'll do. That'll do. Right, back here. So we will do console dot write that, and then program counter equals CPU dot dis that open bracket program counter. Okay, what's wrong with you? You short, that's why. Right, so we don't need that. So we print that line out, update the program counter, and number of lines plus plus. Right then. So we need to put a program in. We need to put a program in, boys and girls.
You wrote one in Notepad.
I was just going to cheat. Where's the online assembler? 6502 assembler. Assembler online. Here we go. Is that the one? Yeah, right. So LDA hash 0. Store it in $74. LDX hash $10. Oh, transfer A into X. There we go. Then store it in $20, X, and store it in 1000, and store it in 1000, X. Push LSR. Right, that'll do.
What, no RTS?
Oh dear. Okay, whatever. Right, there we go. So let's copy that and let's build this up. Let's build this up. So paste that in there. And download binary, standard binary, generate. Where did it put that? Oh, there it is. Console apps 6502 debugger, and we will right. So let me just check my load. Right, so it's a so I need to bring in an array of bytes. Right. Okie dokie spooky nokie. Right, so cool, testing my knowledge here. File stream. Right. Let's do this. And then do this. Right, so using that, what you complain about now? Oh, comma, file access read. No, come on. Excuse me while I fight this. Right. You've got overloads. Come on. Here we go. So. No, I don't want that one. I want path and mode. That's the one I want, which is this. What's it not liking about that? Put an at in front of... Really? No. Okay, I've done this today at work. Alright, we'll use the file then. We'll use the file then. Whatever. Oh, you still messing. Oh, come on. Hello? There we go. Right. Now what you complain about. Really? No, that's not right. No, it's not. Didn't think it was. I must be missing something. Oh, I know what I'm missing. That. Oh, I get confused with all these different languages. Right, so we have a file stream. So we should be able to go program equals stream No, not crypto stream. Stream. Thank you. Dot. Read the lot. Right, okay, so it's different. What do you mean discard underscore? Rubbish. What else do I need? Offset. Don't want offset. I've got the byte array. That's what I want. There, read all bytes. Don't need a stream, don't need a stream. There we go. Oops, I've got slashes all over the place. Don't know what's going on there. Right. Get rid of that. Get rid of that. Do that. Right. Okay, so that should give us... Right. Let's do this. What am I? F11. Nice. 16 bytes. That's what we have. 16. 1, 2, 3, 4, 5, 6, 7, 8. Yes. Get in there, John. Right. You don't need to put the double slashes. Use at in front of the path for that. Is that right? So it does. Right then. So we've got it to read the programming. So I need to then write the program to the buffer, to the memory bus. So dot load program. So we'll take that out and we'll leave that there. So we should have a program loaded in 0 page. So let's have a look. Oh, get in there. Here we go. Look at this, boys and girls. We've got a program listed. Get in there. Let's just do it again. Nice. Nice, nice, nice. Right, so now we've got a program listed. So let's see. Let's do this here. Let's see if we can forward do it. So forward and we're gonna go 0, 1. Right, and what is your counter, program counter? Right, so CPU dot registers dot program counter. Right. Oh yeah, program counters not right. Here we go. Come on, give us 5 lines. Ooh. Unable to cast object of type where list iterator. Oh, do I have to return an INumerable? Right, okay. Okay, then I will do that there as well. Whoa! Whoa! Now you shouldn't need the cast either. Okay, hang on. Let me sort this green out. Right. Let's do right. So if number right. Oh, we are so close. So close. I don't understand why that green's coming out though. There we go. There we go. But I need 2 spaces. I need 2 spaces.
Green background doesn't work very well with white text by it looks of it.
Yeah, I was just thinking that, mate. But what I need to do is I need to put this in here. In there like that, and do number of lines. Right. Yeah, well, we can. I think we can sort that out. I think there's a foreground colour. There we go. So console colour dot black, and then just turn it back to white here. There we go. There we go. Green text or make current instruction black text with, but I think text colour change would better. Yeah, done it. Done it, done it, done it. Right. Right. So I'm still not happy with that. Right. Still not happy. There we go. There we go. Do I need the dollar in front of the program counter? Yeah, right. Let's put the dollar in front of the program counter. Put that. Put that. Trying to remember. It's not come out right. That's not come out right. So there's a bug. There's a bug. Right, let me copy that. And we'll paste it in here. Right, so Studio Code, come on, do it properly. Right, so it's rendering these wrong. Let me run it again. So that's right, that's wrong. Right, so, okay. So it's reading the operand wrong. Why is it reading the operand wrong? Oi, John, pay attention to chat. Oh, yeah. I'm not sure if I mean I can try and change it, but I know about the dollar sign in front of the thing, but I don't know if it would work in this scenario. Anyway, the disassembler's not working, so we need to go in there and have a look. I need to oh, hang on. Hang on a second. Copy and paste problem.
That's better.
There we go. There we go. Oh no, you have a dollar currently in line. Yes, it's to signify hexadecimal. That's what it's for. Yeah, it's to I know about the dollar outside of the quotes for injecting values into a string, but I don't think it would work for that. But in this particular situation, a dollar means hexadecimal. Yeah. No. It's no. It's that we never point fingers except when they're pointing at me. So now we've done the easy one, which is going forward. Now we need to do the opposite direction. And we need to do it by lines as well. We need to do it by lines. So how are we going to do it backwards by lines? Right. So let's do something about this. So if we're doing that was 5 lines on the screen, wasn't it? Or was it 6? 1, 2, 3, 4, 5, 6. Right. So we are going to put this at line 7. Right. So that's where now we're going to fill this bit in with our backwards interpolation. So, what is... Oh my god. Hello. Is that... Have I just been raided? Have I just...
Yep, they are party of 151.
No. Hello, raiders. Who's done it? Who's done it? Retiring
Hello,
progress.
John here.
Hello.
Thank you for following.
Retiring
Hope you
progress.
enjoy the stream.
Hello, retiring progress. Welcome. Hello, everyone. Welcome to my small stream.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Hello, everybody. Hello.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Oh, thank you for coming and visiting my small stream. I
Hello,
hope you
John
guys
here.
had a good stream.
Thank you for following. Hope you enjoy the stream.
Just to give you a bit of background. We are writing.
Hello, John here. Thank you for following. Hope you enjoy the stream.
We are writing a book to teach
Hello, John
noobs.
here. Thank you for following. Hope you enjoy the stream.
To teach noobs the 6502 processor, right? So we've got a book that's about 70 pages so far.
Hello,
But
John here.
we
Thank
need
you for following. Hope you enjoy the stream.
we need a way of showing the user how the instructions work. So we're writing a very basic 6502
Hello, John here.
simulator.
Thank you for following. Hope you enjoy the
Hey,
stream.
old school, old school. Next namesake. You've come from the future. Here
Hello,
it's already
John here.
December.
Thank you for following. Hope you enjoy the stream.
Welcome. Yes, we're not quite there yet. So we're trying to build a basic
Hello, John
6502
here. Thank you for
simulator.
following. Hope you enjoy the stream.
And this is what we've got so far. And what we're trying to do is we're trying to...
Hello, John here. Thank you for following. Hope you enjoy the stream.
We're trying to provide the tools to go with the book. Yeah? Almost the same. Yeah, almost the same. So we're trying to produce the tools to go with the book. Yeah? So this is going to be the debugger stroke
Hello, John
6502 emulator.
Thank you for following. Hope you enjoy the stream.
Oh, look at all these follows. So this is the 6502 simulator debugger, and it's going to allow the noob, the newbie, to be able to walk through an instruction and be able to see what's happening on the screen. And the reason why we're writing it in the console app is because we want it to be able to be run on a Windows machine, a Mac machine, and a Linux machine. So it's been written in .NET as a console app, so we can compile it for all the different operating systems. And so, in conjunction with using Visual Studio Code and Kick Assembler, we'll be able to give the reader the tools to be able to work through the examples in the book. What's 6502 used for in today's market? Well, I don't know about today's, but I think it's still used in things today. But for retro, it was the BBC Micro, the Commodore-based machines, the NES used it, Atari used it. Any other makes that used the 6502? I can't remember off that. Oh, you guys are going through it as it is. Right. Oh, the Super Brain 101 used the 6502. Right. Okay. So we're in the middle of trying to build this little debugger program. So we're just working out the user interface at the moment. And so we're writing it in C# because some of the guys want to know how to code in C#, and I code in C# for professionally. Oh, the Apple. Yeah, the Apple used it as well. Yeah, the Apple used it as well. So yeah, so we're in the middle of writing the book, and we're just trying to get the tools together so we can start working the examples out and be able to put them instructions in the book. So we're writing this simulator debugger thing, and then we can go back to the book and start working out the examples of of how all the instructions work in a 6502 CPU. So yeah, it's modern and retro in the same thing, but that's what we're trying to do. So this is going to be a long running thing because I hate writing books. I'm a coder. You know, coders don't write documentation, but we have to. So it's yeah. So that's what we're trying to do. So that's the background to what you're seeing on the screen at the moment. So it satisfies two things. One, some of the guys want to learn C#, so here we go. And two, we're now we don't have to. It's what ChatGPT is used for. Yes, that is true. But I class that as cheating. I class that as cheating. But thank you guys for sticking with us. So what we're trying to do now is we're trying to reverse the disassembly backwards. So it's dead easy doing forwards, but backwards we're going to have to work out. And so we need to backwards disassemble for 5 lines. So we've got to work out what the opcode is, how many bytes it is, and work backwards to then work forwards. If that makes sense. I think. Yes, I think that makes sense. So yeah. So that's what we're trying to do. So we're just trying to figure out how to work out the backward instructions so we can go forwards. And I've just thought of something as well. We could use this if we can work backwards. We can still use this forward instruction to go forwards. Right, let's write another function to work out. Whoops. Let's write another function to work out the backwards. So how far do we need to go back 4 lines? There we go. That's a good function. So if we do int number of lines, so if we set the number of lines in, so how far do we need to go back, and we'll make it, in fact we'll make it say again.
Just call me PTT, sorry.
Oh, that's alright. So we'll make it a U short. So we'll actually send back. We'll send back the address that we need to start from. So we need to pass in the address then. So if we do program counter like so, then we can pass it back. So return 0. We'll just do return 0 just for the moment. Right. So we need to work backwards. 64 if 11. Oh, of 100. Well, it's all right. It's all right. If you know, if it's all right. I got rated by 151. I think, is that the record now? What was the last? 132 was the last time, wasn't it? So that's a new record. Right. So we need to work backwards. So we got the program counter. So we need to. So our logic was to look 3 back, yeah? Cool, apparently I've been dropping frames. Right, so we need to look back. So we need to check 3 bytes back. So, right then. Oh, no, yeah, bytes back. So we'll set that to 3. And int new program counter equals program counter minus that. Right. How are we going to do this? How are we going to do this? Because how are we going to... Oh, how are we going to I am just...
Hello, John here. Thank you for following. Hope you enjoy the stream.
Oh, thank you for following. Right, I'm just going to do that. I'm just going to see if it's going to fail. I'm just going to see if it's going to fail. There we go. Right. It'll be interesting to see what that's going to give us. So, let's put that in here. No, we'll put it afterwards. In there. Number of lines, 5 for the moment.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Oh, thank you for following. Who's followed? Thank you. Yeah, that'll do. Right, so let's put a breakpoint on that and let's find out what it's going to do. Right, so F11. So, new program counter should be... Oh, right. Oh, get in there. Did it right? Oh, did it? Yeah, it did. Yeah, it did. Right, let's see. Will this work? Right, debug. What's step over 10? Has it found an opcode? Oh, it's done break. That's not what I want it to do. What I want it to do is this. That's what I want it to do. While number of bytes back is greater than 1. Right. Just trying to think this through. If what we get back, what we get back is equal to number of byte backs, If it's not, knock it down by 1. Right, let's see if we get the right thing happening. F11, go in. Set it to 3. Right, so new program counter, yes. Go in. Here we go. Return. Come on. Oh, is it going to go through them all? Rats. Never mind. Is found opcode 169? Okay. And of course, we never find out what that. We never find out what that was. Rats. Right. Let's do this. Yeah. It's all right. It's all right. It's all right. What am I returning? An int. Number of bytes for opcode equals, and we'll do this. Then we can do the tick check. Right, there we go. Right, let's run it again. This time I'm not going to step into it. I'm just going to step over it. Right, here we go. Right, do that. Step over. Right, how many bytes is it? Number of bytes for opcode 2. What has it picked out? I thought I'd set everything to 0. Well, obviously it's not the one we want, so then we go and knock it down to 2 and then try again. Right, F10. Is the number of bytes the same? Yes, it is. Looks like it. Right, print it out. You rat bag. Ha 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 ha. Rat bag. Hang on a second. That should be a valid address. That should be a valid address.
Hold on. Did you say it was looking at a 2-byte instruction?
No, that was just observing that was just observing a byte, not a word. Because I've done the test here to do. maybe the array was too short by 1 byte. Right, let's try this again. Let's try this again. Right, F10 that. So that should jump over that. So we go down to a 2 byter and jump over that. Right, go. Ha, it's done it this time. Right, so what have we printed out? Break. Since when has a break been a 2 byter? Have I got my array wrong? I wouldn't doubt it. I wouldn't doubt it. Have I got my array wrong? That's fine, break. No, I set it to 2. I set it to 1. Okay. Why did that come back wrong then? Why did that come back wrong? Let's do it again. Oops. Wrong key. So it's not a 3. I mean, it's come back. Number of bytes for opcode. Maybe. Full stack developer for 3 years has put this stuff missed. Yeah. Yeah, that's what I'm trying to find. I'm just trying to find it. Right, I'm going to jump in, see what it's coming up with. Right, F10. Right, what is that? Tell me what it is. Oh, you're not going to tell me, are you? You git. Oh, it's returning 169. Why is it returning 169?
Where's it getting that from?
Yeah. Right. Memory address is 0. That is not helping. Because memory address 0, 169 is LDA. So we're not putting the right address in. Hang on. So right, we are programs counter 0 minus 3, right?
Does it handle going below 0 properly?
Well, I'll just find out. 1 minus 3 equals. It should be triple FD, yeah? Right, so let's see what that's going to do. So we get 65533. That's not
3334. Yeah, that's right.
65533. Yeah, all right, so it is. Right, okay. This should be returning 1 byte because everything was set to 0, which is break, yeah? So I'm just going to jump in. I'm just going to jump in again. Oh, look, it's putting 0 into the memory address. So it's always reading 0. Right, why is that doing that? It's like it's not accepting this. Oh, John, you plank. You're a muppet.
Ah! What a plank.
Oh, Saucy did it this time. God, dear. Right. Yeah, my bad. My bad. In front of 150 odd people. My bad. Right, here we go. So we're going in. There we go. That's better. We got the right number coming back now. Right, number of bytes for the opcode should be 1. It is. Yay. Right. So go down again. Number of bytes should be 1. It is, because I set everything to breaks. Now, it should then do... It should match this. Yes. Got ya. Got ya. Got ya. Got ya. Got ya. Right, so that's working. So, when it comes in here, we're just going to get it to disassemble it so we know it's right. Yeah. So when it comes in here, then we need to knock off. We need to knock off the program counter. With the number of bytes for opcode. Yeah, I'm not telling you what mine was. I'm not telling you what mine was. I'm not going to admit that on here. Oh no. Why is that not liking that? Can't convert int to u short. What's u short? Oh, it's that. Okay. Right, so we're going to have to do it the old-fashioned way. And then there we go. Shut up! Shut up! Right. So we redo the program counter. So we will then do number of lines minus minus, and then we'll have another while loop here. So number of lines is greater than 0, and do that. Right. Benny the Cab from Looney Tunes. Yeah, I've had this laugh since I was put on the meds about 8-10 years ago. It's the meds from my heart. Yeah. Right, so when that's done, what we want is this. We want to return that, because that's our start. So when are you fixing the old I don't know. They won't do anything yet. I'm too young, apparently. I assume that I'm going to end up having to have what my dad had. Oh, how long ago is it now? 3 years? It was in the pandemic, wasn't it? Yeah, it was. He had it in the pandemic. So yeah, 3 years. Wow, 3 years ago when he had that. Oh, they calling me? Yeah, they're calling me old. When did my dad have the triple? It was in the pandemic, wasn't it? So it's 3 years ago. Yeah, 3 years ago he had that. Yeah, they're calling me old. Calling me old. Right, okay, so this should give us how many bytes back for the 5 lines. So, let's do it here. You want me to give him a good stern talking to? New program counter. Right. Oh, what am I sending back? Are you short? Oh, hang on. Don't need to do that for that. There we go. Right. So we're going to set the program counter. So with our current configuration, it should go back 5 bytes. So I'm going to just jump over that and see what the... Oh, it's going on forever. It's going on forever. Hang on. It's going on forever. Oops. Oh, you are joking me. Oh dear. Okay. What a plank. Night, D-Type. Thank you for...
Night, mate.
Thank you for joining us. Right, okay, what have I done wrong here? Why did it go on forever? Oh, that's why it went on forever. Got to reset, haven't I? Got to reset that back on every line. Right, let's try that again. Let's try that again. Oh. Did that not stop? Oh, we did. Right. Oh, and I stopped it like a wally. Right, F10. Oh, and it's still going. Okay, right, come on. In we go. Let's find out what's going on. Right, number of lines is 5. And we are number of bytes back, yes. Right, that. Right, keep going. Keep going. Right, program counter. Come on. has gone back and we knocked one off lines. There we go. Right, so it should... Oh, that's gone back in. That's why. But I think that's still wrong as well. Right, so we're down to... Yeah, it's still not right. Oi, John, pay attention to chat. I really need to get some decent channel points.
211,000 sat there and nothing to do with them.
Okay, I'll have to spend some time. I'll have to spend some time on it.
I bet there's people with a lot more than me. I'm relatively young, SP, or new or something.
I don't know. I mean, well, come on. I mean, all the sound alerts are now in the bot. Yeah. So
I don't know. You've been on the channel longer than me, no?
But you've got to remember, right? All the sound alerts are now in the bot, so they don't cost anything. Yes, I need to sort out TTS. Yes, I do need to sort out TTS. Yeah, we've got to have Nicolas Cage in there telling me how to code. Got to have Nicolas Cage telling me how to code. Oh my God! What's the time? It's midnight.
No, there's. I thought there was a command to tell you how many hours you spent watching.
Oh, I don't know. Yeah, but you doing that has just made me look at the time and look at the time.
Yeah, I know.
Let's get this finished and then we'll call it a day. So that's coming down. That's coming down. Oh, you. Numpty. Right, here we go. Right. No. Yes. This should go through it. It does. Right. Get in there. Come on. Right. Let's restart this. F10. Ooh. Right, we should have the
wrong place.
No, that was just me debugging, mate. That's just me debugging. So we should what we got? 5531. That's the right number as well. Yes. Yes. Right. So let's take the debug statement out. And now we need to modify this. We need to modify this to do it. So number of lines is 10. So I think we need to set in the number of lines. Right, int max number of lines. Oh no. I've got the best idea. We do this -5. And then grab that and do this. make it equal. So if the line is equal to 0, that's our current marker. Right. Here we go. Oh. Night night. Night night, Mrs. Always Kate. Right. Right. So we've worked out the new point. So I'm gonna disable that, but I am going to put it there and say we are going to use that. And we're going to put it on line 1. Come on! Rats! What? Something buffer? Right. Oh. Is that a throwback from the number of lines? Yes. Right. Okay. Right. Let's try that. Get in there! Right, let's do a test. So that was with the program counter at 0, yeah? So let's put the program, let's set the program counter to we had 16 bytes. So if we do 08, right. No, come on. That's not fair. Come on. Here we go. Back into it.
What were you thinking?
Oh dear. Right, what's the program counter? 8. Right. Okay, so we're on right, here we go. So we're doing 3. Number of bytes. Oh, I've gone in there. Right, so that's 2. That's fine. So we do 2. Oh. Okay, what's 8? Where's that code gone? What's 8? 0 is a break. So it's there, isn't it? 8D. It needs to go. Oh, right.
So really, your program should never be at 08. Program counter.
Yeah. So the program counter needs to. So we need to set it to 07. Yeah. Because that's never going to work, is it? It's gonna error. That's why it come back with nothing. So we'll set the program counter to 7. Right. Come on. Oh.
Not for this book, Proton.
No, mate. We're not going to teach them illegal opcodes. Right, my logic here is not working.
But it was working.
Yeah, it was working.
What does it return if it can't find an opcode?
Nothing. It's supposed to come back with nothing. Let me just put that back in and see what it's actually coming back with. So that... So we set it to that, didn't we, there? $8D0010. Yeah, that's right. So we set it back to that. So it's still not doing it, is it? It's missed the store out, hasn't it? But it's trying to do an ASL as well. So the logic can't be right. The logic can't be right.
Decoding the STA as a...
That's a 2-byter. It should have caught it. Right, let's step through it and find out what it's doing. Oh, I forgot to put the breakpoint in. Let's step through it and find out what it's doing. Right, go in. So it's going to look back 3 bytes, which should be an illegal code. So number of bytes is 1. So what it's done... Right, what I'm going to do is I'm going to copy that code, this. Go away, go away, go away. Stop it. And we'll put it in here. So we know what we're doing. Right. So it's found 1 byte. So it's gone back 3. So it's found the TAX. Yeah? So it's found the TAX. That's what it's found, which is the 1 byte, which is not right because it's not a 3-byte opcode. Yeah. So then it goes back and says, right, I'm looking for a 2-byte opcode. So it works out going back 2, which is at 5. So 0, 1, 2, 3, 4, 5, which is right. So it should find it. So if I do that, there we go. It's coming back with it's come back with 2. So it should go into here and then 5, 0, 1, 2, 3, 4, 5. Right, let's print it out. What is it printed? Ah, there it is. There it is. So it's done it. It's found it. So maybe it is doing it right. Maybe it is doing it. Store tax 71. Ah, it's picked out ASL. That's because it's on 0.
Oh, it should be on 1.
Yeah, hang on. Right, so yeah, so we need to run through it a few times. Right, first things first. I'm going to put a here. I'm going to put a console write line. to bring the cursor back so we can see what it's doing. Right, so we'll go in. And we know that it's going to pick out the right instructions to start with. So that's the first one. That's the second one. That's the third one. Right, let's have a look. Yeah, so it's done that. So this is the one that's going to have a fit on. So the program counter is 4 minus 2, which is 2. Right, so that goes to 2 lines. Oh. Okay. Found it. Found it. Yes, I thought you might have a bit of a problem. That is a different thing. Right, let's run through it again then. So instruction 1, there we go, that's instruction 1. Instruction. Oh. Oh. Can I break out of a while loop?
Yeah, but I can't remember how in.
So if I, instead of doing that, put break to make it jump out the while loop, that will be fine, yeah? Okay, let's try it. No, it's still erroring on the opcode. Why is it erroring on the opcode? Okay, let's step through it. I'm going to step through it slowly this time. Right, so the first, so this will be the first. Right, prints the first, breaks out. Number of lines is 4. Set the byte back to 3. Program count is now 5, which is right. So number of byte back is down to 3. New program counter is where's new? Oh, 2. There we go. So 2. What's 2 going to bring us? 0, 1, 2. Oh, hang on. New program counter is 2. 0, 1, 2. That's STA. Which is 2. And we're on 2. Oh, hang on. Number of bytes for the opcode is 2. Oh, number of byte back is 3. Okay. Yeah, that's right. So, number of byte back is 2. New program counter is 3. 0, 1, 0, 1, 2, 3, which is 74. Oh. Right. Okay. Okay, right, okay. Right.
Did I miss some? How did program counter get back to 3? You should have found a 2-byte instruction at 2.
Right, I know what the problem is, but I'll run through it again so you can see, mate. Yeah. So we start off with the program counter at 7, yeah? So we then do -3, which gives us 4, which is going to give us something that we don't want, yeah? And then it finds, now we're on a 3 byte, which gives us program counter 5, which is 0, 1, 2, 3, 4, 5, which is the STA. So that should come back as a 2 byte, which it has. And then prints out that STA 20,X, yeah? So that's now put the program counter to 5, because that's where the STA,X is. 0, 1, 2, 3, 4, 5, yeah. So we start now with 3. So 5 minus 3 is 2, yeah? Which is wrong. So now it does a 2 byte, which is 74. Right? So 2 byte would then put us there. And that's where it's failing. It hasn't got an opcode for 74. And that's why it's failing. Boom. So
I think that's what I was saying earlier about if it doesn't find it, you need to return something that says I haven't got an opcode.
Yeah. So basically, I need to create a duff opcode. It's a totally weird syntax in C#. If it works, or first or default, then do null check. Oh, you mean return null? Okay, I get you. I get you.
Because you've got to say, I haven't found anything, but I've still got to keep looking for a valid instruction.
Yeah. So, go to. So, I need to put a trap on this then. So I need to put a trap on this, don't I? Just trying to figure out which one I need to put a trap on. And I'm in the wrong place. Oh, instruction set. There we go. Rather than first, hang on, first throws an error, default returns null. Right, so you're saying there's first or default like that. Okie dokie. Now, oh, I've forgotten what I was going to do. Oh, it's in CPU. Okay, it's in here. Right, so if this returns a null, that means this is going to error. Well, let's do it. Let's see where it's erroring now. Go. Yeah, it's erroring there. I can put a try round a return, can't I? What am I thinking?
Can I just return number of bytes as 0 and it should carry on? Oh, you're doing it that way anyway.
Yeah, because the error's here, we've got to trap it here. So I'm going to do it here as well. And then just return 0, as in 0 bytes, because we'll never have 0 bytes. We'll know that's an error. Right, let's see if it does it now. See if it does it properly. Oh no, it's not doing it. The return's not catching it. Oh, but then again, that's done it. That's done it.
Yeah, read chat.
Oh, debug. Okay. Hang on. Let me. Yeah, that's done it. That's done it. Oh, you beauty. Right, hang on a sec. Let me get rid of the debug lines. Let me get rid of the debug lines, which is that. So if I build it, and I should be able to run it. Where are you? Where are you? Right, debug bin. There. Right then.
Can't I just get it to return 0 instead of null?
No, because that's what that default does. It returns a null. It will return a null. So that's why we capture it on the one down, the one that's calling it. There you go. Look, it's done it.
Oh yeah. No, I'm just thinking. Yes, search for an instruction. If it doesn't find a match, return 0 rather than null somehow. I'm no C# at all.
Well, because it's a class that we return back, you can't return 0, yeah. So the function returns back an instruction class, so you can't return 0.
Okay.
So we just check for the null, but that's working. God, that works. Look at that. Hang on. Defaults, properties. I don't like this font. Right, let's boost the font. Let's boost the font. There we go. But it works, look. It works. Right, so. And the program characters are the right place as well.
Yep, looking good. Nearly done. That's it, ship it.
Can we do one thing, please? What's that? What's the one thing? I won't be able to. I'm not going to do it now because it's like 20 to 1 here. I know what you think. I know what you're saying. I know what you're saying. I will look at it. I will look at it. When making. Oh, hang on. Oh, you're in London as well. Oh, okay. When making the list, add group by. Okay. Let's to dictionary. Okay. Let's see if I understand what's been asked. But I'm not making a list. I'm only... Yeah, but... Oh. At the end, and declare the file type as dictionary short stroke instruction. Underscore instruction is filled. That list or array. But I'm not returning an array. I'm only returning one. Oh, when it's made. Oh, I see what you mean. You're talking about here? This. That's the one on the return you can add. What, here? Okay. Oh, capital. Your spelling is... It's alright.
I in dictionary.
Can't be as bad as mine. Alright, so you're saying then we need to change this
Ah! What a plank.
We need to change this. And change that then. To that. But now all these are... Yeah, the operator. That's why I did it that way. Yeah, when I'll look into it. I'll leave them. I'll leave it. I'll leave it in there. I'll leave it in there. And I'll have a look into it. Yeah. So, ooh, list. And this, that was too enumerable, that was that. And we will do that. And do that. So that should be back to how it was. Dude, you give so many subs out. Why aren't you subbed yourself? These are all right. Okay. Yeah, I'll create a branch and I'll see if I can do it the other way. But yeah, the operator is important as well. Yeah. Is Doc still around? Right, I want to see what this font is. I like this font. Consoler 24. Right, Consoler 24. Let's go back to this. Double it. Consoler 24. Consoler 24. Go. There we go. I like that font. Right. So the last thing I wanted to do before I call it a day is this. Right. So and 0. Oh, let's do start Y. Put it there. Start Y, but I've added a line. So that. Oh, I've added a line. No, I'll put it at 0. -1. I'll put it at -1. There we go. Run. There we go. Oh, that's a bit dull, isn't it? That's a bit dull. Oh, it's two dictionaries. Yeah, that. Yeah. Maybe. Oh, I don't know why this. What's this white? What's this white? Hang on. Dot. Is there a default? Is there a default? I bet it's that. Yeah, it's that. It's that. Right, we're back to. John, does the emulator indexers work properly? Yes, they do. We have got the code in there to test for the. You're on about the crossbound, the page boundary. Yeah. Yes, it does. I'd forgotten one, so we put it in. All cases. The only one that we ain't. The only one I
John
haven't.
here. Another subscriber. Stay a while. Stay forever.
Oh, thanks for subscribing. The real. Is it the real MKB? Real. Well, thanks for subscribing. In all cases, yeah. The only one we haven't done is the indirect jump, which I will code because I forgot it. So yeah, that's the only one that's not done. Yeah. All right then, guys. Right. So a 5-hour stream again. Right then, guys. I'm going to call it there. I'm going to call it there, and we will be back with this next time, and we'll try and see if we can get it done. Zero padding. Yes. Yes, I've done that as well, Proton. I've done that as well. All right then, guys. Right, I will see you in the next stream. You never know, I might be tomorrow. All right then. Take care, and I'll see you soon. Bye.
Bye all.
I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.